So making petrol, this is the summary slide, and I thought it would be helpful to just show this first because there's quite a lot in this, but when you break it down, these are your key points. So there's not that much in it. It's just a case of understanding what's written on this slide. So to increase octane number, you want isomerization. So branching caused by alkanes heated in the presence of a suitable catalyst can form isomers of that alkane. So like we looked at structural isomers of butane and pentane were ones you needed to know, and they'll come up in questions on this as well. So for example, like we spoke about here, we've got pentane. This is 2-methylbutane. If you were to get your other structural isomers for pentane, you would have another increase in octane number. So these are isomers of each other. You have the same number of carbons, same number of hydrogens, but the one that's the isomer, the one that has more branches, is going to have the higher octane number. Step 2 is way number 2 is catalytic cracking. So long chained hydrocarbons are broken down into short chain molecules, for which there's a great demand. Large alkanes are going to be broken down to form an alkane and an alkene. So again, if we were to look here, with heptane that we have here, if we can crack that using a catalyst, and cracking just means breaking this bond here, we can make 2 shorter chain substances. And if we can do that, those 2 shorter chain substances are going to have a higher octane number. So we can increase the octane number of heptane, sorry I said hexane there a while ago, by splitting it, by cracking it using a catalyst, to make it into 2 shorter chain molecules. Reforming is the next one. This involves the use of a catalyst to form ring compounds, and hydrogen is going to be a product of that. So again, here we've got hexane and we've got cyclohexane. If you look at the formula of hexane, you've got your 6 carbons, which we have here, and we've got how many is that? We've got 14 hydrogens here. Whereas if you look here at cyclohexane, we've no double bonds or anything. Don't get it confused with benzene. We've only got 12 hydrogens. So to get from hexane to cyclohexane, we did this reforming, also known as dehydrocyclization. I can't say it. I'll move on. The reforming process will take 2 hydrogens off of here, C6H14, to become C6H12 in the cyclohexane substance. So you've got a straight chain substance becoming a cyclic compound, and you've got hydrogen left over. And then finally is adding oxygenates. 3 oxygen containing molecules, methanol, ethanol and MTBE, are added to petrol to increase its octane number. We'll come back to that at the end of this video. We'll just go into a little bit more detail on each of those for anyone that might need it. So first of all, petrol, when you're making it, first thing that we can do to help reduce the amount of knocking is by adding a substance called tetraethyl lead. Now the addition of lead has been stopped. It's illegal in Ireland because of the health impacts lead can have. So it can damage health because it's poisonous. And it causes lead pollution, and also it's not great for car manufacturers because it poisons the catalysts and the catalytic converter. So the reason for these 4 ways to increase the octane number, those were found because we had to replace lead as a solution. So again, I've given a rundown of each of these, so we'll just quickly go through them again in case you need to. Isomerization is changing straight chain alkanes into their isomers. It's done by heating the alkanes in the presence of a catalyst, and this causes the chain to break. So when we add heat, some bonds are going to break. When they join together again, the final product is more likely to have branched chain alkanes. An equilibrium mixture of straight chain and branched isomers is usually formed. So what that's telling you there is you have your long chain alkane, you're breaking some bonds in it, and you're hoping that when they join back together, instead of just getting your straight chain again, what will happen is you'll get some isomers, you'll get some branches added on there. And now that's not going to happen to every single molecule. Some of the molecules are going to just form the straight chain again. So that's what we're saying here about the equilibrium mixture. It's not going to be all branched isomers, but it's going to form a mixture of the straight chain and some branched isomers, which are what we want. Catalytic cracking, you're breaking down the long chain molecules into shorter chain molecules because those have a higher octane number, so there's a greater demand for them. It's carried out by heating the heavier fractions in the presence of a catalyst. And what usually happens here when you take an alkane is that it's converted into branched alkanes or alkenes, which are both equally useful. The branched alkanes are used in petrol, the alkenes are used as feedstock for the petrochemicals industry. So just to show you that here, a bit of a representation, you've got C12H26 here. So we would heat the chemical in the presence of a catalyst, and what would happen is there would be a cracking happen. So this bond will break. That will open up these two carbons on either side of that bond. They're going to have to form a bond with something else. And so what's happened here is that we've got two shorter chain molecules, which are first of all going to be more useful, just the fact that they're shorter chains. But also what has happened is we've got a bit of branching happening here. So ideally, when catalytic cracking happens, you're not only going to get shorter chains, you're also going to get branches off of them. And that's going to make it a much better fuel, a much more efficient fuel with a higher octane number. Another example here, again, what you'll notice, we got an alkane and an alkene out of that. And you'll notice here again, we're getting an alkane and we've got some alkenes. So there's usually going to be a mixture of substances here. And again, you know, it depends on how efficient your reaction is. You might end up getting some straight chains back again. There's another example there. Let me see if I can say this word now. Reforming or dehydrocyclization maybe. So just breaking that down, dehydro means the loss of hydrogen, and cyclization, I said it, means ring formation. So we talked about that, if I just go back for a second up here. So we went from hexane to cyclohexane. So dehydro, we removed H2 from it. 2 hydrogens are removed, going from 14 of them to 12 of them. And the cyclization, we've got the straight chain molecule becoming the cyclic molecule. So just let me scroll back down here again. So what's happening, straight chain alkanes are converted to cycloalkanes. Cycloalkanes are converted into aromatic compounds which have high octane numbers. So remember, your definition for an aromatic compound is something that contains a benzene ring. So that's the end goal here. And we've kind of went through that. So hydrogen is usually produced, so instead of reforming, sometimes it can be called dehydrocyclization. I got there eventually. So here we go. This is the steps involved. So you've got hexane becoming cyclohexane, and then cyclohexane becoming hexene. Here we've got methyl cyclohexane becoming methylbenzene that we've seen before. Again, you need to be able to draw that one out. or name it, and hexane just becoming benzene in one go there. So these two here would kind of go together, and if you were to put them together and do it out all at once in one step, this would be your reaction. And this is just another example for you there. Adding oxygenates. So what is an oxygenate, first of all? It's a fuel that contains oxygen in its molecules. So the oxygen containing compounds that are added are methanol, ethanol, and MTBE. So what that stands for is methyl tertiary butyl ether, and that's what the MTBE stands for. And you do need to know that. You need to recognize it at least. Hopefully they wouldn't ask you what it stands for, but they can. So you need to recognize that. As well as increasing the octane number of petrol, another advantage is that these give rise to very little pollution when they're burned. So as we saw when we were looking at catalytic converters and all of that, we know that the gases produced when you're burning fuels can sometimes be dangerous or can cause pollution, and adding an oxygenate will mean, so these are cleaner fuels, I suppose is what you could call them, and they give rise to lower levels of carbon monoxide in the fumes that they produce. That's pretty much it for this section. So what I might do is just stop the video there now. They're just the structures of methanol, ethanol, and MTBE. Again, you don't need to learn off, especially methanol and ethanol. In chapter 22, we're going to go through the alcohols, and you have to be able to name them and draw them like we have done with the alkanes and the alkenes and alkynes. So don't worry too much about that. That'll become second nature to you after the next chapter. So I'll stop there. Any questions you have, please go to the Microsoft Teams page and you can ask them there.